Welcome back to our channel. We're back with another educational video, and today we're diving in to discover why Homo sapiens evolved to become lactose tolerant while some Homo sapiens didn't.
Make sure to give us feedback to let us know if this video is helpful. We got a lot of positive comments last week on our physics video on Newton's laws. Now, without further ado, let's get right into it. Every newborn has the ability to make lactase, an enzyme that helps the small intestine digest lactose. As you get older, your lactase levels start to decline, which means there's nothing stopping the lactose you're consuming from going straight to your colon undigested.
The real question is, why do some adults still retain the genes that produce lactase and others lose it? In our research, we found that lactase persistence was an adaptation to pastoralism, which means that dairy farming preceded the evolution of lactose tolerance. The evolution of lactose tolerance took about 200,000 years, which is the equivalent of a hot minute in like the scheme of the evolution of Earth. So it would have taken very strong selective pressure for people to become lactose tolerant.
The ancient Neolithic farmer, milk was like a superfood, and even lactose intolerant adults could have benefited from it. Chemical evidence from ancient pots shows that farmers learned to process milk into cheese or yogurt, which lessened the amount of lactose.
Just when humans began to milk newly domesticated cows, and goats and sheep, mutations near the gene that produces lactase became more frequent. Around the same time, adult lactose tolerance became more frequent.
The mutation responsible for that may be between 2,000 and 20,000 years old. A combination of two reasons may explain the persistence of the lactase mutation in Northern Europeans.
First, the farmers that settled there came from the Fertile Crescent, and they brought crops native to that region, like wheat and barley. But with Northern Europe's shorter growing season, these crops were more likely to fail, causing a famine.
Additionally, the colder Northern European climate lent itself to natural refrigeration. If you're a farmer in Southern Europe and you milk a cow in the morning and you leave the milk out, it'll be yogurt by noon. But if you do the same thing in Germany, it'll still be milk.
A healthy lactose intolerant person who drank that still fresh milk would get a bad case of diarrhea. But a malnourished lactose intolerant person would die.
In times of famine, milk drinking probably increased. And the very people who shouldn't have been consuming high lactose dairy products, the hungry and malnourished, would be the ones more likely to drink fresh milk. So, with milk's deadly effects for the lactose intolerant, individuals with lactase mutation would have been more likely to survive and pass on that gene.
The lactose tolerant person wouldn't have had an evolutionary advantage, but for short periods of time, the mutation would have helped. In the long run, it's modest, but at times in history, it was a very high selection. There was enough variation in the Homo sapiens species that many, if some, individuals possessed the gene. Due to unfavorable weather conditions like famine or drought, those who had the gene to produce lactase would be selected by nature, and therefore they would live on to pass on their gene to their offspring, and so the cycle would continue. So although it was very crucial at the time that people evolved to become lactose tolerant in order to survive, now you might just be lactose tolerant because your ancestors survived it.
The body creates lactase when it's instructed to do so by the LTC gene, and over time, that gene can become less active. The result is lactose intolerance, which can begin after age 2 but may not manifest itself until adolescence or adulthood. Dr. Grand says the 13910T allele is the single nucleotide polymorphism located close to the lactase gene that provides not only one of the best examples of gene culture evolution, but also one of the strongest cases of recent selection on a gene being documented.
The fact that the same allele does not predict lactose tolerance in Africa suggests that lactase evolution occurred recently to the spread of modern humans around the world, as predicted by the cultural historical hypothesis.
The osmotic effects of lactose and its fermentation products cause the symptoms most frequently associated with lactose intolerance.
Today, 35% of the global population, mostly people of European ancestry, can digest lactose without a hitch. But according to NIH, people of African, Jewish, Asian, and Northern Native American descent do not commonly possess the lactase gene.
Some people have different levels of lactose intolerance, so they can eat cheese and yogurt but can't drink milk or eat ice cream. This is because cheese and yogurt has a lower lactose content due to how it's made. Taking lactase pills or drops, such as Lactate or Milk Dairy Ease, before you eat can also help manage symptoms. You can also look for lactose-free alternatives to milk and milk products in your grocery.
The study of the evolution of lactose tolerance is very useful to science as it supports, evolution. It is fairly recent in the history of the earth, which makes it easier for scientists to document. To understand lactose tolerance evolution, we must first understand natural selection. In order for lactose tolerance evolution to have occurred, the lactase gene would have had to be favored by nature. This means that the Homo sapiens species would have had to been producing a large number of offspring. There would have had to be variation in the genes, a limited food source, and those traits would have had to been passed down. The lactose tolerance evolution is a great example of natural selection. And since natural selection is a very important component for understanding evolution, lactose tolerance supports the indisputable evidence of evolution. The different gene mutations that mimic the lactase-producing gene stemming from early Northern European settlers creates an opportunity for scientists to study and draw scientific conclusions on gene mutations and microevolution.
Over the past 50 years, the dairy industry has changed greatly. In the US, 60% more milk is produced from 30% less cows than in 1967. This is because each cow produces over 2.5 times as much milk as 50 years ago. Vegans, however, protest the dairy industry, believing it to be better to have a plant-based diet. They might choose to be vegan for a number of reasons, including believing farming to be cruel to animals, for a healthier diet, or to better the environment. These are some of the reasons the evolution of lactose tolerance has affected our society.
Throughout my research, I discovered that majority of Africa's population was in fact lactose intolerant. And I started to ask myself, why was it I, who migrated from Africa, could tolerate lactose? I did some digging, and I found my answer not on the World Wide Web, but in my own family history. See, on my dad's side, he's Dinka. His tribe exists in South Sudan. And the special thing about his tribe is that the people consume a lot of cow's milk. In fact, the cow is very sacred to the tribe. And this got me thinking. And when I related that back to my research on how Northern Europeans became lactose tolerant, I found out that the similarity was dairy farming. So there must have been some time in my tribe's history where there was a famine or a drought, where the only source of nourishment was cow's milk. So to this day, that made such an impact on my tribe that the cow is so sacred to them. And children and adults alike drinks cow milk. So therefore, the individuals who just by chance possessed the gene that could produce lactase survived and thrived during that time. And they lived on to pass their genes, whereas those who could not produce lactase either died or became terminally ill. Therefore, I am a descendant of one of those individuals who survived the famine.
When we started this project, what really interested me about lactose tolerance and intolerance was my own family. My sister was lactose intolerant while I am lactose tolerant, and I was wondering why this was. Well, it turns out that the variations that promote lactase production are considered autosomal dominant, which means that only one copy of the variation in the gene that promotes lactase production is needed for a person to become lactose tolerant. So even though my dad isn't lactose tolerant, because my mom is, I inherited the variation that allows me to be lactose tolerant. Because my sister didn't inherit the variation, she's lactose intolerant.